Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. Joining me every week is Mr. Pedro Ruiz.
What's going on, everybody? I'm Pedro, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, as we combine 3D printing, DIY electronics, smash them together to make some inspirational projects that you folks can build. Let's jump right into this week's coupon code. It's Master Blaster. Hello everybody in the chat room. Welcome to the show. We are kicking it off with, well, the coupon code. So if you want to check out anything in the Adafruit shop, this coupon code will get you 10% off. It works on everything in the shop, except for two things. He knows which ones they are.
Could it be Ada boxes and gift certificates?
Yes, we have those, and those are still really good things to get, but the 10% off works on everything else. We also have some really interesting free deals. The more things you buy, the more stuff you might get for free. So go to adafruit.com/free to see all the lovely goodies that we have. They change on the weekly, and there's while supplies last. Sweet. Same day delivery is an option for folks that are in the New York City area. So if you are in New York City, you want to get some parts, and you need it that same day, that is actually a shipping option, which is really nice. We got newsletters as well, adafruit.com/newsletter. That's a once a week newsletter that has all of the new products that get added on the weekly. We also have subsets of newsletters for your inbox. This one's adafruitdaily.com. You have to subscribe to that one and pick what categories you like. It's a standalone website, again, adafruitdaily.com. Check out CircuitPython, check out 3D printing, and the other ones as well. We're hanging out in the Discord chat room. That's right, Adafruit is on Discord. We have a Discord server. The invite link is right above there. It's discord.gg/Adafruit. We're hanging out in the live broadcast chat room. There we are. What's up, Mr. Certainly is hanging out. Hello, everybody. Hello, y'all. Woo. Excellent. So, let's see here. Do we want to go through the jobs board?
Yeah. We're still looking for some positions over at Adafruit. I think it's the PHP developer, but it is open to everybody, not just job seekers, also job posters.
Yes.
So definitely check that out. It's free, no spam.
Correct.
Nice and safe for employees and employers alike.
Yeah, make your profile. It's free to do so. If you are a maker, you might get some gigs, some extra caches for your maker skills. Excellent. So that's the jobs board. Again, jobs.adafruit.com. Cool. All right, I am ready for this week's project.
Yay, this one has been a long time coming.
Yeah, this one is awesome. A couple different hands touched this one, and we are super happy and excited to share it with y'all. So we got a Learn guide. So go to learn.adafruit.com. It should be right there in the front top, or you can just search for Zelda Master Sword, and hopefully it shows up. Yeah, there it is. We got a YouTube video as well. That's a nice 5-minute breakdown of all the steps and all the things that you can do. These files are open, so everybody can make it and 3D print it, and the code is all written in CircuitPython, so it is really easy to update the code. And we're actually going to do that. We're going to do some live code changes to see the thing actually change live, which is pretty good. So,
yeah, so ever since we released the Guardian Sword, it's been the most popular prop that we've released out there. There's been so many makes, so many remixes. The one thing, though, that everybody continues to copy and redo is the way that the electronics were inside. So
yes, that's
featured
right.
a trinket and the little charging circuit and some NeoPixels in there. The problem is there is a lot better way to do the animations and the boards that we have now available.
That is right. What boards are they? They're actually right here. We have, they're right there.
There you go.
Yeah.
Yeah, so before we were using trinket, we had to have separate boards to actually handle the charging, and we had to use Arduino, which is not the friendliest.
For beginners, yeah, it can be a little bit daunting. You got to download the IDE, you got to make sure your board profiles are set up and updated. This one, we're hoping that the cosplay community takes a look at CircuitPython and seriously starts incorporating it into their projects. It is definitely one of the best ways to really change and iterate your code on whatever computer, because it works like a USB drive. You don't have to convert your audio files over to like .h files. They are native WAV files that just about any computer can support. And we have this set up in a really nice configuration.
I need to reiterate that again. You plug this into your computer, it loads like a flash drive. All your code is right there, all your sound effects are right there, So you can edit the animation, you can change the color.
That is right.
As we've seen,
if you plug in your Guardian Sword,
just now,
what's going to happen?
As we saw last night, it now works on iOS devices. And iOS 13, you can just plug it right into your phone. You can check out all of your code, edit it while you're on the go. So that is the standard that we're trying to set now.
Right.
So this couldn't be possible until now. A lot of libraries, a lot of code.
Yeah, we're on version 4 of CircuitPython, which is the best, for 4.1 rather, which is the best. It has really good audio support, so it's really easy to play back different audio. And really, the Prop-Maker Featherwing is making all these props possible. That's why it's called the Prop-Maker Featherwing. It has built-in accelerometer. It has built-in circuits for powering 3-watt LEDs. It's got a built-in amplifier, so if you want sound effects, you want lights, it's right here. You even have a little potentiometer right there if you want to update the gain on the volume. Built-in speaker port, built-in NeoPixel port right there. All of these right here are little extra pins that you can break out and add things to. And this stuff right here is that 3-watt RGB LED that you might have seen in our lightsaber build. And that just has everything you need. Also little breakouts for switches if you want to kind of do some button inputs.
Which we utilize all those.
And the Feather M4, you definitely want to get yourself a Feather M4. It's got more RAM and it's got more flash, so you're going to run those NeoPixels at 100%, which is really great. And the best part is, it's got battery charging right in it. So as you're uploading code and changing code, the thing's going to be charging in the background. It can charge and edit code live. So let's go ahead and turn it on and like swing it around.
One last thing I do want to mention is you also have like strain relief, little holes in there for all your cable.
That's right.
Nice little management with that. So without further ado, let's see what this sword
How do you
does.
turn it on?
We have a little slice right here, has a startup animation. We have an idle animation with sound effects going. And then we have our blaster code. So if you swing it like that,
give it a little jolt.
Bam. You get your little blast code going on. And then you also have clashing going on.
There you go.
Like that. And then you can even do your combo hits.
You want to do the full screen as well?
Let's go over to this screen so you can see. So we actually, this is original design by Garrett from Chaos Core Tech. He modeled this a couple years ago, and there has been several remixes with people adding their own, like hollowing it out, adding electronics to it. Unfortunately, it is the same like trinket and doing it in Arduino. Right. So of course we had to update that. Did a lot of updates to the mesh. We actually made the blade a little bit shorter so a child could play with this. You can see the size comparison.
Yeah.
This actually isn't the full scale. I actually chopped one section off of that just to make it a little bit easier to swing around. Because if you've ever built a sword before, you know, the longer the blade is, the harder it is to swing around. Found that out with building the lightsabers. So we wanted to make sure that these are nice, simple battle, easy to, you know, play around with. So that is one of the modifications we had on that. Making the blade a little bit more friendlier and updating a lot of the mesh to accommodate the electronics in here. So we're using a high density NeoPixel mini skinny NeoPixel strip on this to fit inside the blade all nice. And we're using a low density on this one, which is low is like 60 pixels per.
Yeah, you could probably see the spacing there with the exposure in the camera. You can really see it.
The reason we did that though was, you know, save on cost for the build of materials. And because the little one is shorter, we were able to utilize the higher density one on this one. You can see the difference on that. See how much more dense and compact all of the LEDs are on that.
Yep. So it's up to you if you want to use more pixels. Obviously you're gonna get a lower battery life perhaps. And what is the battery life like? Well, it's a 2200 milliamp battery. It is rechargeable, so you can charge it up when you have it on for several hours. Yeah, I really like that color. So what we're gonna do is we're gonna walk through the guide.
I think if you go over to the overhead, you can see how you can reprogram and recharge your board. We have a little USB extender that is on the end of the handle here. It's a little micro USB jack. We also have a reset button here if you want to go into CircuitPython. And we have a mode change button as well, so you can have it change different colors or have audio play if you don't want any motion to be part of the action of what's happening.
Yeah, or you could use it for whatever. We broke it out so that it could be a bit of a future-proof in case you want to add some new things to it.
All the components are laying inside of the handle here. You can kind of see, where is the, oh, I didn't even do the, oh, here it is, the,
the
speaker holes for that.
You do want to add these. These are added after the 3D print. They're not incorporated into the model because it's actually much easier to do it after the fact. You don't need support materials this way. So that's really smart to do it that way.
We got the slide switch that is turning all of the components on and off there. And then the NeoPixels are all laid. You kind of see them here inside of the blade.
Yeah, I really like the infill pattern, kind of shows through. It makes it look kind of like this crystal stuff. Definitely want to use triangular infill because it just matches the Triforce, right?
Yeah.
So those triangles really make it look good.
Yeah, so the main feature of this, of course, is the blasting animation that Lamar wanted in there.
Yeah, she's like, I really want this prop where you swing it and it does this sort of shooting effect. So if you were making a ray gun or something, you had like a gun, this would totally work really well with it because it's kind of shooting that. Well, it depends on how you lay out your strips, but I think that'd be really cool to see that. Sweet. So real quick note on the sound effects. I actually layered these together using a sound pack from Video Copilot's Motion Pulse. So these are like movie grade sound effects that are layered, and I also captured in-game audio of Link going, hurry up, ah! You can hear it doing it. And the really cool thing about it is instead of just repeating the same sound over and over again, we have a random choice that basically has 4 swings and 4 hits. So as you're swinging and hitting it, CircuitPython is just running through the loop and saying, okay, let's pick this one, okay, let's pick this one. And it's all completely modified. You can increase the amount of sound effects. So if you want more of them, you just add it to the list in the top of the header. We're going to take a look at that code as we're walking through the guide, but right now it's more of a little show and tell right here. So this is really fun.
Yeah, detail in the handle. We got the little rope detail that goes on there. It's actually holding the sword together.
Yeah.
So we're just using paracord for that.
Yes, paracord. Yay.
And then the rest is hot glue with the air duster acting as accelerant to hold everything in place, make it a lot more easier to mount all the components since the original design didn't have any standoffs or any mounting holes. So I wanted to be on the other side of the coin where people just build remixes of projects. And I didn't want to add any extra geometry. So all of this is held with Gorilla Glue.
Awesome. Gorilla Glue?
Well, it's Super Glue and the Gorilla brand of hot glue.
Oh, word. Okay, and we'll take a look at the hot glue gun too. It's cordless, battery operated, really nice.
Yeah.
One other thing I wanted to talk about before we start jumping into the guide is you'll notice that there's always a looping sound effect in the background, and that's actually to prevent like noise and static from happening. So if you have your prop, you kind of want to have some sort of idle sound effect that's looping in the background, because then it'll always have a nice sound as opposed to just sounding kind of like crackly and noisy, which is pretty interesting. Lamar was like, hey, we should definitely have it. So I found this kind of really nice, like mystical ambiance humming that's in the background that really matches like Legend of Zelda. It really matches the theme of it. So I hope that works out. You hear like little birds chirping in the background and stuff. It's kind of interesting. So that's really cool. Let's go ahead and take a look at the overhead. I'm going to update that and make sure this is on manual exposure so I can expose it a little bit better. There you go. It really blows it out there like that. But yeah, are you ready for the Learn Guide?
Yeah, let's go ahead and jump into how we actually built all this. Is a lot of soldering techniques. Crafty techniques is what's making all of this possible. Let's go ahead and jump into that.
Yep, we'll answer your questions definitely at the end of the walkthrough of the Learn Guide because we want to walk through this. All right, so let's go ahead and jump into the Learn Guide. So again, learn.adafruit.com. Search for Master Sword or just Zelda, and you'll see all the different Zelda builds. The overview page is going to cover all the parts that you need. This is all the parts. Again, the hero is the Feather M4 and the Prop-Maker Feather Wing. We got a little mini oval battery speaker, which is really nice. It pumps out a lot of sound, especially when you have it in a nice kind of a spot where it kind of housing will definitely amplify the sound. That's what I'm trying to say. We also have some extra odds and ends like these micro USB connectors. If you have an embedded prop and you need to extend that USB, these guys are the thinnest and smallest ports that you can find. It also comes with a little plastic housing. So we have the female version of that and also the male version of that. Definitely pick these guys up for your projects. You can see that the housing can come off here, and then you can solder directly to this little guy. Yeah.
And we have a different amount of these USB plugs, but these are the smallest if you want to fit them inside of a little tiny spacing.
All right, and then the other hero is the actual NeoPixels. They're not, they're regular NeoPixels, but they have the 3535 NeoPixel LEDs, which are right over here. Oh my goodness.
Oh, we forgot about that.
How could I?
We'll put it in there.
Oh no.
The other thing that
was do this, yeah. So if you just search for mini skinny, this is the best way to do it, mini skinny. You're gonna have a lot of options. We were talking about the 60 mil, 60 per meter, right? This one. So it's $25 and you get the meter. We're actually using 2 meters of it. 2 meters. And you can click on this button right here. It gives you 2 meters. And these are really, really nice NeoPixels because they are the super slim and skinny, hence the name.
They're about half the size of a regular strip. And they come in black PCB and white PCB.
Oh, that's right.
So you can match whatever
the
prop
you have
is.
So if we hit the back button, you can get a good idea of it. Here's the white one. Here it is. And I'll hit the 2 meters. I'll copy that and we'll add it to the Learn Guide right here, edit this page. That's so funny that I forgot to add not the most important part, but it's definitely a critical part. This is how we update our Learn Guides. Really, really simple. Wait, did I do that right?
You can just put the product number in.
That is the product ID, yeah. Two. That's not the right product ID. There it is, 2959. Yeah, it's me being silly. There it is. Add that in there. And also add it to the featured products part here.
One of the other heroes of this, the parts list, is the silicone-coated ribbon cables.
Not a lot of people know about these, I think. So you like the colored ones, and those are really nice. But this stuff is bundled in a ribbon, so it's super neat. So if you have something that has 5 connections, 4 connections, definitely get the 10-wire one because it has all the 10 wires. The only kind of downside, that I don't really think it's so much of a downside, is that they're not color-coded. There's only one labeling on them. There's one with like a little gray line.
But this makes it a lot more easier to bundle inside of a tight space.
Exactly.
They also won't melt when you're soldering to tiny little pins.
Yeah, super flexible. So they're not going to break as easy as the PVC regular wires that are like a part of the headers and stuff. So those are definitely a recommendation there. And the other thing is the 3-pin JST connectors. This wire plugs directly into the port on the Prop-Maker wing, and a lot of other boards as well, like the
recent boards have this.
All the stemma connectors are all going to work with this. It's got data, power, and ground coming right off of it. And yeah, it's only like $1.
A couple days ago, Lamar and Phil released a full video on what is stemma.
Yeah, all the different connectors and stuff.
Check that out.
Yeah.
There's 3-pin, 4-pin.
Cool. I think that's all of it. The battery, there it is, it's the 2200. And again, the circuit, the charging circuit is right on the feather, all the feathers, so you don't have to get an extra board for that. Where's the audio board? It's all a part of the Prop-Maker. Where's the accelerometer? It's all in the Prop-Maker. So there we go. That's the front page. We got these nice photos that we took of it as well. So cool. Nice, okay. Nice catch. We caught that NeoPixel, threw it in there.
Yeah, so one of the first things you want to do is actually program your board so it's nice and ready to go after, right before you start all your crafting, just to make sure all of the code is on there. You can test it while you're laying all of the components inside the prints. So if you're completely new to CircuitPython, any one of these projects is great. This one, definitely. We have a quick start guide that walks you through exactly what you need to do. You plug it in through USB, double tap on that reset button, and download the latest UF2 version. So real quick note, this is CircuitPython.org. It is the best place to get the latest version of CircuitPython running on Adafruit hardware and hardware from the community. So you can, there's just a lot you can see here. This is a really nice visual way to kind of see all the different boards, hardware that supports CircuitPython. All those libraries and things all work on these guys, which is really awesome. So real quick, as a quick note, is that this is the Feather M4 Express. So I'm going to click on that. You definitely want to use the 4.1 RC
the release candidate, and not the 4.0 version. The 4.1 has a lot of speed improvements, code optimization, so you're going to get the best performance out of your hardware using the latest, even more latest than the stable. So definitely get the beta release. Well, it's not even beta, it's RC now, so check it out. Definitely you want to do that. Cool, so back over to the Learn Guide. That's going to give you a direct link to that page that we were just looking at. And then this is a really good little bullet list of the libraries that you want. So you can download the CircuitPython library as a bundle. It includes every single library. You don't want to put every single library on your hardware, on your drive. You want to put it, you just want to grab these 3 that are particular for this project. So you got the Adafruit bus device for talking to I2C devices, the LIS3DH was a little helper library for the accelerometer, and the NeoPixel library, which is going to give you all the functions for animating NeoPixels. So those are the 3 that you want for just about any Prop-Maker project. Sweet, so we got a nice zip here that you can download. This button right here. Actually, this one talks about the Mu editor. Sure, you could use a text editor if you want to edit the code. We like using the Mu editor because it has a built-in serial console. We're actually going to look at that in just a few moments. And it runs on Windows, Mac, Linux, and the Raspberry Pi, which is really nice. So you can edit Python in just about anything. And the Mu editor is pretty lightweight, too. So it's supposed to be meant for beginners and as simple as possible. When it comes to the audio files, again, I got a huge credit to Video Copilot, the Motion Pulse, so I have that linked here as well. And the...
yeah, well, we can't give away the source files for this. We can give out the mix of all of the sound effects that are used.
For whatever reason, the code's like not here. That's the weirdest thing. It was here yesterday. Maybe it got clipped when it got updated. So let's go ahead and pop it in here. So it's going to be in Learn Guide, the repository over GitHub. This is where all of them are stored. And I'm just going to type in Master Sword Prop-Maker. Here is the code. Let's go ahead and pop that into the Learn Guide. Again, it either got deleted or something happened. Okay, but it's in there now. And what you can also do is download the sounds as well. Let's see if I can clip this out, and then I think it'll give me a project zip. Maybe. I'll come back and revisit, but it should give you a link to download the whole repo. Not the whole Learn repo, but the repo, the sub-repo for the Prop-Maker Sword. So let's click on this preview here. Make sure it shows up. You can click this button right here that says Project Zip, download that, and it'll have everything. And then you can also click on this link that says View on GitHub. It's trying to load the content in here because it's kind of got this special embed, but the code is right there, as you can see. We also have it linked in the YouTube videos, but it's all right here. And it's heavily commented. We're going to look at it now. Is that cool?
Yeah, go.
It's funny. We gotta make sure our guides got the latest links and stuff. All right. So what we're gonna do is we're gonna go ahead and plug it into the device on the bottom there. So as you see, there is a little orange color that shows through that depicts, hey, this thing is charging right now. So as soon as you plug it in, it's charging. Depending on how much paint you apply, you might not see the orange or not, but it is there. You can see that it's charging. All right. Now you got to turn it on. When you turn it on, the switch is hooked up to the enable pin and the ground pin, so that'll turn it on. So CircuitPython is running right now, and it's going to mount on my drive. And it's mounted on my drive. What I'm going to do is switch over to our Mu editor, which I have over here. And I think this is the camera that I have set up for it. So you can have it just right here. We're going to look at this, and we're going to change the colors. All right, so what you can do in the Mu editor is hit the load button up here. It's going to quickly go to the CircuitPy drive. So when your Feather is set up, you will have the code file right here, your audio files, and your libraries. So let's go ahead and open the code file. There we go. And this little guy right here called serial, this one is going to print statements. It's going to make some print statements and let you know what's going on here. So I'm going to load it again using Control D and Control C. And it tells you it is playing the on effect, and now it's playing the idle effect. So When I shake it, you'll see that the serial console now tells me it has played swing 3 and it's now playing idle. So as I do that, you can see, you can get a good idea of how random the random choice is, which is the sound effects that are happening there. So that's the best way to kind of get a real live way to get print statements in the serial console. And it worked right away, awesome. So let's go ahead and change some stuff. So right here you can see we got a comment that says customize the colors here. The idle is light blue and the hit color is orange. It should say orange. So what I'm gonna do, this is my older code. So what I'm gonna do is just comment these out. And I already have 2 that are set up here. So I basically just copied and pasted these 2 lines. And now I have RGB values. So RGB over here, and then for the all color, same thing, RGB. So these values, if you know your RGB colors, you can figure out what colors they are. But for now, let's go ahead and hit Command Save. You're gonna see that it quickly restarts within a fraction of a second. And now we have this like pink red sword.
Wow.
That when it's got this kind of purple color that shines through it. Completely changes the look of it. I mean, you can see like the texture of it here flowing through it. It's like a mad version of it, which is really excellent. And that's really quick and easy to do. So if you're modifying this code for a different prop, it's so easy to do. You also have other things like the threshold of the accelerometer. So the hit threshold is currently set to 600. If you want to be more sensitive, then you have smaller numbers. It says here, smaller numbers means more sensitivity to the motion. You also have the swing. We wanted to kind of be easy to trigger the swing, so that's what we have to set to 150. But you can play around with that. Also, the duration of the power on is 1.7 seconds. It should be the length of the seconds that is the length of the actual audio sample. In this case, it's called on.wave because that's the power on sound that we want to play. And you can completely change the startup here. Let's see if I put 1, what happens. It'll probably start up quicker. Yeah, that starts up way quicker now. And again, to test that out, I could come into Mu and do Control C. That stops the code, and then Control D, that kickstarts the code. So you got that was really quick to do. And it still works really well. You can also change the duration of the kind of blast, the beam, down here in the one of the functions. But it's all commented, so you can come in here. If you wanted to add more sounds, you want to add it to these 2 lists of sounds. So we just name them like this. You don't have to put the wave file in here because the code it looks for or appends that .wave file. So that's why we have it swing 1 through 4 and hit 1 through 4. So these are the, it's kind of like the array, right? The list of the sound effects that we have here. You could also change the, if you haven't noticed, there is a pulse that's happening on the idle animation right now. So it's slowly pulsing on and off. If you want to make that faster, you can put here 0, and that would make it a little bit faster. You would see it pulse a little bit faster. So that's really cool. Down here in the actual main loop, you can see kind of how it's running. You got the main power on mode that's happening here, and it's playing that. This right here is how you can play the wave. So play wave, it's the idle, and you want to loop is equal to true so that it keeps looping. And the power over here, you can change that here if you want, and that's just applying that and playing the power on sound. Down over here, you can see how it's reading stuff from the accelerometer. You have some if statements here saying if the accelerometer total is hitting that threshold, then actually play this sound. And right here, play wave sound. This is where we added the random.choice, and then there's the variable hit sounds, which is that list of those hit sounds. So that's how we're able to play multiple sounds in just one of these lines. You got some modes over here, and then we have mode number 1 over here, and so on. So you can come in here and definitely change it as you like if you want to add more modes, or if you want to modify the brightness of anything, it's all here to do so. Very, very awesome. So hopefully that gives you a good idea of just the depth of customization you can make to these props.
So you could take the circuitry, this code, and apply it to your own prop. As Oscar on the YouTube chat is saying, this reminds him of the Thundercat sword.
Oh, sweet.
So that would definitely work in terms of updating the colors, the timing of the animation to fit whatever prop
yes.
you're trying to make.
Exactly. And you could even come in here and add the fancy LED library and add some really stellar gradients and animations. We might do that for the next project, but as you've seen, this code has been kind of evolving from the very beginning. It was the original lightsaber that we did, I want to say like the beginning of the year in January, and that's just slowly been getting more and more features, and we keep iterating on this piece of code, and it's getting more and more robust, I think, which is great. And the performance just continually gets better. So if you got
Scott and Cackney update all the code, do the refinements to the way the framework's all working, updates to the libraries and all that, it is going to get faster, better, stronger.
I'm looking for my my colors so I can revert here. All right, so I just commented those out. I'll get those back and make sure to comment these out. And this can live in here in the code. It's on the drive. So one of the things you kind of have to start doing is remembering to save locally to your computer, whatever device is editing the code. Because, you don't want it to disappear and be like, oh no, it was only on the drive. So we're back to normal here, back to that light blue and that orange hit.
Very nice.
So excellent. And it's been recharging this whole time. The battery's been recharging. You can change the accelerometer too if you want. Let's go to the second overhead. Is it this one? Yeah, the bigger overhead for you. You can see I could expose to it too if you want. Let's go to aperture priority, and I'll let you see all those details in there. Yeah, exposing for something that's really like light, it's kind of difficult. So thankfully you can quickly change some aperture stuff over here with the webcams. Really nice. Really happy with the sound effects too, man. I spent a good amount of time on those.
Yeah, the original sound effects out of the game are not as detailed or
they're a little under
just depth.
Right.
Super cool.
Yeah, there's a lot in those sounds, man. Very, very cool. So I hope that gives you a good idea of how to modify the code and how it can be remixed to whatever type of prop. Sweet. Going back over to the Learn Guide, that is the software page. Let me refresh, see if that code got updated. Yes, sir. The code is now embedded live in there. Shout out to Lady Ada herself and Katney Rambo for hacking on this code and making it available for everybody. It's using the MIT license, so you can use it as you please. As long as the text above is included in any redistribution. Cool. Again, comments, lovely stuff. Check out the Moo editor. All my sound files are available to download through this Project Zip, so just click on that button right there, that link that says Project Zip. All right, let's go over to the circuit diagram. This is a good visual way to see how all the wired connections are. We are using those 2 NeoPixel strips, and with 2 NeoPixel strips, we're sharing power, data, and ground. It only takes those 3 connections to get a NeoPixel LED strip running. Battery connects directly to a little extension for the battery port, but there is a battery port right on the side of the Feather M4. You can see the reset button, the reset button is broken out so that we can actually get to it. Speaker gets fitted right into the speaker port, and we have a nice enable and ground pin for the switch that'll power they'll turn on and off the 3-volt regulator that's on board the Feather, so that you can power off and still recharge. You definitely want to cut power using the enable pin as opposed to cutting power from the battery, because then you wouldn't be able to recharge the battery. Yeah. So really, really clever power circuitry that is included in all Feathers. Really awesome. And a little quick note about the way you want to mount your headers on your Feather. When you got your Feather, definitely don't solder those headers yet. You never know what configuration your project will need, and if you've already soldered it, it's kind of a pain to unsolder it or maybe desolder it.
Yeah, you were telling me that somebody actually soldered these on the wrong side down here.
They're not wrong. It just depends on this configuration.
Yeah, you need to use it. So this would not have worked for us. I tried the smaller headers so we could take it apart if we needed to. But because of the size of the handle, I didn't want to update that, and I wanted to make sure that it was nice and small. So we're actually not using any of the headers and soldering directly to the Feather
the
M4.
female headers. These are the male
so
headers, which come pre-assembled now with the Feather with the Prop-Maker. We have a version that is particularly already
definitely
assembled.
recommend, because it was a lot more harder trying to get this to align properly, since I didn't want to go ahead and chop off the JST connector for the battery. I wanted to have it sandwiched as small as you could get, so it's about like that small. And then as you see, there is a gap here, so you can route all of the wires that are being broken out for the slide switch, the action button, the NeoPixel strip, and the speaker is being routed under there as well. So a nice little circuit sandwich here, the smallest you could get to fit inside of the handle.
Yep, you could get it even thinner too if you cut off the little JC port for the battery, but you don't need to. It can stay there. So this is a look at the regular sized headers that you would probably see, and if you plug in the Prop-Maker here, you can see how much kind of chunkier it is. So fitting it in a really tight space. This is how kind of standard it is. There's a lot of clearance in between the two boards, which is nice for some projects, but for this one, you definitely want to go as slim as possible.
I was saying before, we do have female headers that are a little bit shorter, about half the size of this, but that was still a little bit too tall.
Right. Yeah, a lot of folks don't know that. We have short versions of headers, male and female, but sometimes even those aren't as slim as you need.
Yeah.
So there you go.
Oh yeah, Imagination to Form is saying that he had to do the same thing to fit it in his project.
Excellent. Yeah. Yeah. So again, the other tip is don't solder those headers until you know exactly the configuration for your project. Yeah. Very cool. Let's hop back over to the Learn Guide and see the lovely wiring diagram. So this was put together with Fritzing. We got the Fritzing software over here. We got a library as well if you want to create your own lovely wiring diagrams. You just click and drag, and it's really easy to do these type of wiring diagrams. It's always nice to say. And this is really, really handy. This is the wire links for all your wired connections. It tells you exactly which wire and millimeters, so you'll have to convert those to inches
yourself. These are pretty exact. You just use centimeters on a regular measuring tape that I use for all of these. But you want to get these as close as you can. This includes the actual ends that you're going to cut off to tin the connections. So especially for the USB extender there, you definitely want to make sure it's really at 20 millimeters. Otherwise, it'll be too big or it'll be too small.
Yeah. No room for slack on that one.
There's a little bit of room for slack just so that you can lift it up while you're mounting it to the inside of the handle. So definitely make sure they are pretty exact, as close as you can to them. Otherwise, I had to build 3 of these swords. So if you didn't get it exact, you have to go back and re-strip all your wires and try again.
Excellent. Okay, well, paracord. If people are wondering what is a paracord, that's the rope that's tied around the handle. That's cool that you put that there. You also want that length. It's kind of like a wire. I didn't know that was in there. Good. All right, let's go into the 3D printing part. Here we are. All of the parts are printed in translucent PLA. We stock some as well, but there's definitely different types out there. We're just using regular PLA. You can test out other materials if you'd like, but for now, this is what we use. We use PLA, translucent from Meltink is the manufacturer. And of course, this is a huge shout out to Garrett Kearney. He runs the Chaos Cortec YouTube channel. You can watch his build video here, and you can subscribe to his channel right there. Garrett's a really awesome guy. He does a lot of open designs as well, and just lets them out to the community. And really, if Garrett didn't, open his files, we probably wouldn't have done this.
So would have been modeling.
Right, so the modeling. And then a shout out to the person who remixed the STLs to actually fit the electronics. I think it's this one. Oh, this is ours. And then there's what's cool about Thingiverse in the page is that you can see all of Garrett's remixes. There's quite a few of them.
And remixes.
Yeah. So this is a derivative, and this is the original. So it all kind of links back to the original creator. He's got 48 makes, so quite a few people have built this sword.
So it works.
And quite a few people have remixed this as well. We're number 9. This is the one that inspired us from Tom Smith Creations. And shout out to Tom for actually crediting and saying, hey, this was inspired by the Guardian Sword that you did a couple years ago. So the Guardian Sword, again.
We already talked about this in the beginning, using the trinket, using Arduino.
Yeah.
Sort of set the path for how all of these are being programmed and what boards are using. So what we're trying to do with this one is reset that, have the standard be Feather, CircuitPython, so you can edit all that, have it load like a flash drive.
It's not just a light up glorified flashlight anymore. It's got sounds. It's got a speaker. It's got an accelerometer.
You can actually program different motions, so you can do up, up, down, down. It'll do like
Cool.
like
you
a secret
step detection too with the accelerometer.
Yeah.
Oh man, the sky's limits over here.
You can attach different sensors. You can attach, more
NeoPixels.
the 3-watt LEDs.
That's right. So you
so
get
much you can do with it.
LED, yeah, sweet. So this is kind of a good little story. So he was inspired by the Guardian Sword that we built, and he said the next step was to take Garrett's already awesome model and remix it for the electronics. So he shelled it out, he hollowed it out, but he designed it for the CR10S5, which has a whopping 650 by 525 millimeter bed. We don't got that.
Yeah.
We got a pretty big printer, but that's really big.
It's huge.
So you really have to modify this. So thankfully, Pedro brought this into my ducked STLs and modified it so that it fits on any of the Ultimaker 2s, 3s,
Prusas
and
as well.
and Prusas as well, which we know a lot of folks have the Prusa. It's got a pretty decent build volume, but it's not 500.
Yeah.
It's like, dang, that's so huge. So if you can see his STLs here we had to cut them up. So Pedro cut it up and kind of cleaned up some of the errors that we were getting with the STLs. So
Just some mesh errors in there.
Okay.
So hopefully the standard should be when you design a prop now, make sure that it's completely hollow so there is room for adding your components on there.
correct. So jumping back over to our spot here, you can see how we printed them all.
So
Really,
that I chopped these up. One of the things I did do was I eliminated one of the sections to make the sword smaller. It is a huge blade, and when you're swinging that around, it's not the easiest to maneuver around. So
Yeah, if
make
you're-
sure it's smaller.
yeah, if you're going to modify the STLs, just keep that in mind. You're going to need a lot of LEDs, a lot more than what we
more.
have here, and it's
Yeah.
going to cost more, and it's going to cost more in terms of battery life. So
That
don't
is
forget
correct.
that. Don't forget that. If you want to, it's really easy to just say, I want 100 LEDs.
Yeah, but then you can't
when
really
you do
swing
that,
around.
somehow your animation is a little bit slower because it's got so many LEDs. Maybe it's too bright. Maybe the battery life is reduced. That's why we're using the 60. It's just, you got to find that right balance of how many LEDs we want. All right, and what's the cost? Yeah, so huge shout out to Garrett and folks for remixing it. It's a really good open design, and we thought we'd remix it as well. Fusion 360, Garrett's design is actually on the Fusion 360 gallery. It's kind of an I would say, at least folks that don't use Fusion 3. So here's his post, the original post. It has the sheath, what is it called? The sheathing as well?
Oh yeah, the little
sheath?
the thing that it goes into.
Yeah, and you can clearly like zoom in on this. You can get a parametric timeline. This is a fantastic model, so you can modify this to your heart's content. Garrett did a fantastic job releasing it, so you can see it, and great video too. So check it out. We got links to everything from there. And Garrett, if you're watching, update your YouTube video so that it has that link, because I couldn't find this link anywhere other than manually searching on the Fusion 360 site. So hopefully folks know that. It's been like 4 years, so it's time to update it. All right, when it comes to slice settings and whether or not you want
Position of them,
Yeah.
that they are too. They should be ready to go. I printed them as they are in the STL, and the reason we did that is because the flat parts, the way that they're laid down, is what's going to sandwich the two pieces together. So I just wanted to make sure those were absolutely flat. We used a 7mm brim to ensure that the corners didn't lift.
That's a pretty large brim, and one of the best ways to remove it is to have a deburring tool, which is what we're using here. Deburring tool has that little curved edge, and it's
45
meant to
degree.
kind of do circular curved objects, and it works really well to get rid of those brims, or you can just snap it off and use an X-Acto knife. But this one's really nice, nice one.
After that, cleaning continues by sanding the edges so that you can make sure that the parts that are going to adhere together line up without any gaps. And then for adhering, we're using our favorite Star Bond medium dry super glue to get all those edges.
That's right.
And then reinforce with the Gorilla hot glue using this very fancy Black & Decker glue gun, which we've showed multiple times. This is definitely would not be able to make any of these without this.
Yeah, it's
super
cordless.
fast, cordless. It's using the whatever battery these are.
Yeah, we already have a bunch of Black & Decker electric tools. So we already have a couple batteries, so we figured, hey, we need to get this one.
Yes, heats up super fast and does an excellent job of not over oozing on all of your parts.
Yeah.
So definitely recommend getting one of these.
Definitely better than those really cheap blue ones that you get for like a $10 at Walmart. Yeah, those aren't any good for industrial projects that have really good strong hold. This is what you want to get. So that's the hot glue, and this is the Star Bond super glue. That fine precision tip, it's really handy for me. Was it handy for you too?
Oh yeah, you don't want to get glue everywhere and get that hazing on your parts, so
it's got a good
have
work
a nice
time.
Precision way to add that. And then the third superhero of this project was
Here it
a
is.
nice tip from Jimmy DeRosta, who was using air duster to accelerate the cooling time on the glues.
So you put it upside down, and you can get some.
Don't do it on your hand.
I've done it.
Freeze your hand.
It's fine. Frostbite never hurt me. So yeah, you can really accelerate.
Because as you know, if you ever used hot glue, you know that it takes quite a bit of time.
Something from this. This is really, really hot glue.
Oh yeah.
You have hot glue, and then you have really hot glue.
Yeah. So definitely have your air duster around to adhere all these parts.
Yeah, we talked about it in the video a little bit, but we might as well mention it again here. All right, moving back over here, that's our trick for gluing and adhering. This one shows you kind of plan out your parts, make sure everything fits once you're done with sanding and you're ready to hot glue. You're gonna wanna make 2 copies of it. Well, actually, they are symmetrical, but not really, right?
Just one has the slot for the
switch.
slide switch.
Yeah, so you wanna be sure of that.
We're skipping a little bit here. It just says painting. You know, we're using the acrylic paint here, but you can use an airbrush or any other ways to paint this. Just make sure you mask off the little details. As you see here for the smaller one, this one's for my kid, so I didn't have to go in there and add the gold because he does not care. He just wants it to glow and make sound effects.
That's right. So it's up to you how you want to sand it, how you want to finish it. Do you want to add primer? Do you want to airbrush it?
Yeah, here's what it looks
you
like
can
when
make
it's
it really
painted.
metallic-y. Yes, that looks really cool too.
You can add like a clear coat or something to make it nice and shiny.
And if you're super skilled at modeling, you could design this for dual extrusion and actually print it out with the filaments, like from Filamentum. They got glitter, royal blue, and gold happens. All those colors are really great. Yeah, if you want to dual extrude it. It's going to be some considerable modeling time, but it is open and it's there. Cool. Back over to the Learn Guide. We got our halves made. Now it's time to assemble.
Halves made, painted, and then we can move on to getting your components ready. We'll measure down the JST battery extender. As we mentioned, all the sizes are listed there. And this is just so that we can keep all of the components nice and small. The thing is sticking out of the sides. The JST battery connector here is sticking out one of the sides. So we wanted to route that so it's out of the back end of the boards. This will be sandwiched in between those guys, and that's just so we can have the battery where we need it to be inside of the handle. So we're soldering directly onto the back of the JST board or JST battery connector here on the back of that, so we can route that.
Okay, once that's in place, I guess we throw the feather
right on top there, just what we talked about earlier. We're not using any headers, but just soldering all the pins directly to that. So flip it over, using a pan of vise here to hold everything nice and level, because there is, one of the sides is bigger, so you can have it sort of at an angle. Yeah, you can have it teeter, so just be aware of that. Make sure that's laid completely flat on the feather.
Okay, once we got that, it's got our feather sandwich. You can start laying it in the handle.
And here we'll just dry fit all the components so we can have a visual of how all the parts are going to get laid out. You can go ahead and start measuring all of your wires here to make sure that they all have enough slack to sort of like go over and below some of the components. You know how everything's in 3D, so the wires have to as well like wrap around.
Right, in between parts.
In between parts.
This one shows you kind of dry fitting your extension for the USB connector and the reset button. It's so close yet so far. You could skip this, and we did that in the beginning, but boy was it.
It's a little difficult to fit.
It is to kind of snake it in there. This way you don't have to snake it in there. You have instant access to the USB port, so you definitely want that because you are going to be recharging and you are going to be changing the code because it's so easy to do so. And that reset button is there in case you want to update CircuitPython when it gets even better, because it seems to get better every week.
Yeah, if you want to be brave and not use this, you totally will still have the ability to reach the reset button with a little, like a little flathead screwdriver. You should still be able to poke it.
We were doing that, but we got sick of this. We're like, let's break this out.
Yeah.
All right, and this one shows you all the wired connections for USB. USB is a little bit special. It's got power, ground, and two, what do you call it, data pins. Actually, 3 data pins. Data plus, data minus, and iData.
Yeah, so a nice little visual here of how to hook up your USB micro to USB micro jack.
Yeah, so you
I couldn't find any good diagram on the internet, so I went ahead and made this for y'all.
Yep, you can click on that and it'll give you a bigger image.
Again, it's only like 20 millimeters that you need to extend this.
Right.
So it's going to be very tiny in terms of soldering the pins.
I would say it's definitely easier to build this than it is to hack existing wire together, because
it'll be too big.
It'll be either too big and too time consuming. This is definitely the way to go.
Moving on to the reset cable, like we mentioned before, we're utilizing the strain relief holes to manage and bundle our wires. So
somebody asked that, like, what are these holes? Yeah, they are for strain relief. So if you're going to tug on a wire, you don't want to tug on the spot where the solder joint is. This kind of adds some relief to the strain when you're pulling or handling this wired connection. So shout out to Lamar for designing those. They're throughout the board here, and we're using this one right here, which is right next to the enable ground pins.
Moving on to the small little, I forget the name of these little buttons.
Yeah, they're called slim tactile switches.
Yep.
They are the slimmest we have. They're 6 millimeter by like 2 millimeter. They're so small, but to fit it inside such a small area, this is the way to go. Because we have really big buttons, and this is the slimmest. Yeah. It's in the name.
So I actually cut off some of the ends there, so they're not so long and don't protrude out.
Oh, the metal contacts. Okay.
Yeah, the pins.
There you go.
Started that in there. Do not add heat shrink on there because it'll make it too wide when you're closing the.
That's a tight spot.
Yeah, it's pretty tight. Yeah. We are going to be insulating this with hot glue once we're adding all the components together. So don't do the heat shrink to that. All
right, so that's the reset button. Now we're going to do the switch. So we're wiring it into the enable and ground, which is really right there. It's easy access.
We're going to have to reroute. We're going to have to route this the way shown there. Otherwise, you're going to get in the way of the USB and the reset button if you ever need to like manually poke it. You know, if like the cable breaks or something. And we're just rerouting this through the between the two boards. It's going to go out the end, as you can see there at the next one, after we solder those together. Again, don't add any heat shrink to the 2 pins there. We're going to be insulating them with hot glue as well. Okay. And I did trim those down a little bit shorter than what the 2 metal tabs on the sides are, just to keep it flush, because the battery is going to sit right on top of that. And you don't want those to poke the battery.
I see what you mean. Yeah, so the pins that come with this slide switch, they're pretty long. You want to trim them short. I think that's what's going on here. Okay. And then after that, we're ready to plug in that 3-pin JST connector to make sure it can fit there.
Yep.
This is where and then start soldering it.
Yep. So you can dry fit it back on there. We'll mount the slide switch in there. Make sure there's enough slack for the wires that we've made for those, and we'll lay out the USB jack and the reset button towards the end of the handle, and then we'll attach our speaker and get it pretty close to where the boards are, right above where the halves of the 2 pieces meet for the handle.
All right.
And then we'll move on to creating our little Y splitters for the NeoPixels. And the easiest way that I found to do this is with the 3-pin JST stemma cable.
Yep. So what header pins right on it.
Yep, header pins on there. We're just soldering 2 wires for each connection to split those off for both strips. You can see the technique that I'm using here. I'm just angling 2 of the wires together, holding it with the tweezer, and then tinning the jumper part of the header on the stemma cable. And then soldering those together. It is safe to add the heat shrink since it will be in the blade. There'll be plenty of room for those.
Yeah, this looks great.
So you definitely want to do this so none of the connections touch.
This is real clean. You want to try to keep it nice and tidy, otherwise it's probably not going to fit.
Yeah.
Yeah.
For the NeoPixel strips, we're going to have to remove the fat, chunky connector that it comes with, as well as the hot glue that's around the start of the NeoPixel strip. So make sure that you identify which direction the NeoPixels are going by checking the little arrows that are printed on the PCB. You want to cut at the start of that, and then measure out how long depending on your blade and what density of strip that you get.
Yeah,
you want to trim those down.
They're designed to be cut, so don't feel bad. They have these little pads. Some of them even indicate cut here, so you can cut your strips. Okay.
Yep. After that, you want to make sure that you power up all your components. Make sure that the speaker's working, the lights are going on. Give it a little wiggle to make sure there's no cold soldering joints. Make sure that everything is nice, solid, has a nice solid connection, and the thing's loose. And after we test all of that, triple checked again that everything is measuring how big it needs to be in terms of the slack for the wires. You can do a little dry fit test by combining both halves to make sure that it actually closes.
It's really visual in the video. You can clearly see that's what's going on. And you want to shake, like you said, shake it around as it's closed. You don't want to pinch or kink any of the wires, so you really want to, don't skip that.
Yeah.
All right, over here you're showing.
So the way that we're actually mounting all this is, again, with the hot glue and the air duster to accelerate cooling down all of that. So we're actually have all the arrows here of where I applied a small drop of hot glue, and we'll want the hot glue to actually drip down onto the parts so that it has a nice adhesion to it. It's going to be all the corners, right on top of the speaker, over the slide switch, and then we're actually hot gluing some of the wires as well so they don't flop all over. And it's also creating a cushion for the 2200 milliamp hour battery there as well.
Yeah, just thought I'd get a bigger look at it. You can click on those. Since it's curved inside, you kind of want to have these set up right here.
Yeah, you definitely want to curve that around to have, so you don't have to cut it to size that, and two, to create that nice little loop that I'm using there. It's creating that cushion away from the slide switch. The battery has a nice little pillow to lay on top of there.
Yeah, nice. All right.
Moving on to adhering the USB jack. I'll just add a drop of that, and then to the bottom and the back of it as well. And that's how we're insulating the connections for that.
The hot glue strips, is that?
Oh, sorry, skip that. Yeah, you want to hot glue the strips as well. You want to keep a nice distance between the edge of the blade and the middle of it, just so that the diffusion is a lot more even.
Will the regular NeoPixel strips fit in there?
I don't believe so. It might be too big.
How did that guy get it to fit?
Maybe use different ones. No, it's the same.
Maybe use different ones?
Yeah.
Or maybe it's...
Or maybe it does. I didn't test it. It might fit, but I'm just recommending the mini skinny just so...
Because you know it does fit.
I know it does, yeah.
Right. All right. So if you already have NeoPixel strips, you'll want to do some testing on your end. And yeah, it is the distance between the edge and how you want it. That's how much light diffusion you want.
Yeah.
Cool. All right. Now on to the USB jack.
Yep, like I was saying before, one drop of hot glue near the edge there, and then to the back where all the connections are to insulate that. And then we're using the air duster to dry that off. Don't add any to the top of that, since that's where the reset button will go on there. We're really tight on space here, so any amount of hot glue that's added to it is definitely going to make it even tighter. So don't add any to the top there. Lay the reset button on top of that, and then add hot glue to the back where the pins are to insulate those.
Oh, nice. Yeah.
That should still give you enough room to close both halves. And then last minute, we added the mode switch button that sits right on top of the reset button.
Yeah, we don't have any code for it right now.
It's just there for
it's
future.
Just there for future. Yeah, because I've had Lamar ask me, why is that extra switch there in your lightsaber? What does it do? It's like, nothing yet. It's like, it will someday. All right, how about we make those speaker holes?
Yep, with the speaker all mounted on there, it's going to definitely sound muffled. So
yeah,
I didn't want to add any holes to the actual model since it would
look kind of dirty.
it would probably have a difficult time printing because of how small you're able to
print in the air like that.
Yeah, you're able to make a lot more smaller holes than you're actually able to print. So we're just using a poking tool. These usually come with your 3D printers. I think this one came with like the Lulz Ball or something. Just heat that up, just use the lighter, and I poked a bunch of holes. Turns out you only need about like 5 holes or less.
You want to be careful not to poke the speaker, right? Did you do this before? I guess you could do it before you start mounting it.
Yeah, you can see here that both halves aren't closed yet.
Okay. Cool.
And it shouldn't damage the speaker since there is like a little cloth before you actually get to the plastic part of the speaker.
Right. All right, and you can see here you can make your own kind of arrangement of holes.
Again, you don't have to make that many.
You don't have to make that many.
You can make like 5 or something like that. Right. Should be plenty. And you want to do this to both sides of the handle.
Yeah, that's a good tip. Yeah, totally.
After that is all done, when you're poking these, it does have a tendency to lift some of the material up, the PLA.
Oh, that's
so
right.
you can go in there, trim it all down with flush cutters to have a nice clean hole.
Yeah, I was thinking like, well, why don't you do this before you paint it? But then the paint would cover up the holes or something. Then you'd have to re-poke them out again. Yeah. So you play around with it. Maybe you might figure out a better method.
After that,
that's how we did it.
So after that, we're going to combine both sides, and we're using the paracord to hold all this together.
Yeah, and some nice tight wraps here. You can secure the rope with some adhesive.
Hold it in place.
Probably super glue.
Super glue is what I used, and I added a drop between where the 2 ropes crisscross. That should be enough to hold it in place.
But you can still take it off and still untie it if you need to, which is great.
You can just cut it, make another one.
All right, now you got
And then the last part is hot gluing the blade together. What you're going to do is just stick the nozzle for the hot glue gun in between where I'm showing all the arrows there for each section of the blade. Squeeze a small bit in each section, and as you were hot gluing each section, you're going to go ahead and use the air duster to freeze dry that to hold it in place.
Yeah, Insta dry. Sweet.
And it holds remarkably well. If you've seen in the video, we had my son Gavin there swinging around, hitting the ground all over the place, and it has been able to survive the hot Florida sun.
Yeah.
When we're shooting this, so it's definitely battle tested by a child. It should hold together.
Yeah.
Really
With
nice.
my lightsaber, I broke it so many times. The Keyblade, I broke it so many times. Even the Guardian sword eventually broke, but the Master Sword, like in the game, it's unbreakable. Cool. So as you build it, definitely share your posts with us. We had a lot of fun time working on this project. We even 3D printed a little Korok over here, which is nice.
Oh yeah.
Yeah.
Tons of really cool
I think
props and additional things to
That's so funny.
add to this link. We got to make a playlist because it's not. I've lost count of how many Zelda projects we've worked on now.
Huh. I can't change the. I can't change the
start, or the in and out.
That's super bizarre. Oh, of course. I really wanted to share this video. Golly.
Checking in at some of the comments in the YouTube.
There it is. Yay. I was just in the wrong element. All right.
Imagination Form saying about mass production of these swords. I would not.
Mass production of the swords?
Yeah. This takes about 5 hours to build.
Folks are
and this is after I've built 2 already.
The Guardian sword on Etsy and their own websites.
You got to sell it for a lot of money because this takes a lot of time to build.
It's a custom build. Whether the files are out there or not, you still have to put the work in.
Yeah. So like I was saying, I built 2, so I know how to build it really fast, and it still took me 5 hours to build one from complete scratch. And this is after...
With no documenting?
With no documenting,
wow. So yeah, it's going to take a little bit.
And when I have to document, it takes quadruple the time.
Oh yeah, it's like the whole week. Almost 2 weeks, yeah.
Shoot all that.
Yeah, so this is just some BTS of Pedro. He was all recorded with his Snapchat glasses. I don't know if you know, but he's got a video camera on his head 24/7. That's how he sees. So this is a good insight into kind of the setup here. We're using lots of pan devices, just one, and in combination with your third helping hands, just to get everything in the shot and nice and level so you can see it. Here's like when we were first prototyping it on the table there. Got my Nintendo Switch because I was capturing the sounds. Using our own tools here. This is a tool, it's a solder fume extractor that we use a lot. It's a little handheld, it's using the power boost, designed by Philip Burgess. We got this nice kit of different heat shrink tubes in different colors and such. We got this one from Amazon. It's a really nice kit to have. And did an awesome job on the documenting. Great job on all the photos, video, a lot of video here. Got a little Adafruit solder dispenser as well, helping out to dispense our solder wire.
All of these are available as free downloads. There's a whole guide on how to build the solder fume extractor and the solder, Adafruit solder feeder thing.
Dispenser, bro.
Dispenser.
I'm out of words, man. We're over time because we just
this took so long.
We really wanted to show the process of everything. That's why I thought it was interesting to show. Definitely give Pedro a follow on social media if you want to see more of this. This is just half of what he's captured, so you can get some real insights into
what's
the
coming
process.
up next.
Yeah, and what's
project
coming up
next. Like this one right here, which we're probably not going to have any time to show. Let's see.
Depends if we want to or not.
Probably not. I'm hungry.
Yeah, I'm hungry too. We got a dog who's going to come down here any minute and go like, whoa, whoa, whoa. So yeah, it was an excellent build. We hope you guys check it out, or at least consider taking a look at CircuitPython in your projects.
All the code is up there, so you can modify it for your own props. As a lot of people in the chat room are saying, this would be excellent for a large amount of different props.
Yeah.
Madi3211 is saying, this is going to replace the bulk of his Arduino hacking and futzing for his Tron disks.
That's excellent. Excellent.
Definitely share that.
Yeah.
I want to dress up in Tron gear while we're on the Tron ride.
And definitely share your files and definitely open them up to the world, because this is how open source works. People will contribute right back, like as we did.
Yep.
These are all free files, free code, free libraries. You could spin up your own board if you want. If you want to make your own Prop-Maker like feather that has like the M4 built into it, I'd love to see somebody do that in the community.
That'd be awesome.
We'll stock it if you want to do that. All of Lamar's board files, Eagle CAD files, footprints are all out there in their respective places on GitHub and what have you. So there you go. Very awesome. That's this week's project.
And I think that's going to do it
Master
for the
Blaster.
show. Make sure you use Master Blaster for 10% off your order.
Yes, sir.
Expires at 11:59 p.m. tonight. But don't worry, there'll be more codes later tonight. It's going to be show and tell, where everybody from around the world shows all of the cool projects they're working on. Somebody earlier in the chat room during the jobs board session was saying that they have experience in 3D animation and 3D printed augmented reality. Are there any positions there?
Yes, come on the show and tell.
This
and
is
share
how
your stuff. That's how we got our job. We came on the show and tell, and we're like, hey guys, we put some lights in a thing. And they're like, cool, that's great. Here's a blue fruit or something. It's a longer story, but a lot of the folks, the remote folks, came on the show and tell, let them know what they're working on, and if there's some interest, Lamar and Phil will contact you and ask you if you want to contribute.
It's pretty much how we do resumes here.
That's how you do resumes. You kind of got to do the work first, show what you've done.
Show your work.
And yeah.
So definitely stop by. We'll take a look at some of the cool things that Lamar and Phil are working on. Right after that on Ask an Engineer at 8 p.m. Eastern Standard Time. We'll see all the cool products that are released, the news in the maker community, lots more. And then tomorrow, another coupon code with John Park. Working on a lot of awesome MakeCode arcade projects and games. Definitely stop by. I think he's working on a Tamagotchi inside of MakeCode for this week's project, so definitely stop by. Lots of video game hardware that we're showing off.
Design video games. Yes. Yep. That is awesome. Cool. All right. Well, don't forget to check out the Learn system. There's a lot of other projects that are out there. Yeah, man, we got some more stuff we'd love to share with you, but we got to get going. So don't forget that coupon code Master Blaster. Your orders really support, keep this thing going. 100% woman-owned, open source company, still manufacturing here in the lovely states of the Uniteds. I think I said that right. Well, that's going to be it from us. Don't forget there's shows tonight and tomorrow. But until then, don't forget to make a great day. Bye, bugs.
See you tonight, guys.
Peace. Wait. Peace.